Yeah, so recording has started. Hi team, good evening. Firstly, thanks to the Professor David Dye for giving us the opportunity to do the presentation and research on the two papers, two very interesting papers, the autonomous agents and multi-agent systems, and the other is multi-agent learning system, learning for engineers. So we are group 16, and I am Sai Kumar, and my major is computer science, and I came in this spring 2022. And I please introduce yourself, guys, so that we can start the presentation.
My name is Teona Velkoska, and my major is computer science, and I'm an undergrad student.
Yeah,
Dinesh.
my name is Dinesh Anavoina, and I came this spring 2022, and I'm a graduate computer science student at Southeast Missouri.
Oh, that's great. So I'm gonna start the presentation. So in between, I'll hand over it to my team. So this is the overview which we are going to cover for paper 1, that is autonomous agents and multi-agent systems. So we'll cover all these topics in the ongoing slides. So the first is introduction to agent and agent-based systems and multi-agent-based systems. So simply, what an agent means, what an agent means is a computer system doing some kind of autonomous action to achieve the desired goals. And there are three main concepts in that needs to be done by an agent, and these three concepts are location, autonomy, and flexibility. So the location in terms of the surrounding environment that we have, so collecting the information from the surrounding using the sensors, and the second concept, autonomy, where after collecting the data from those sensors, we will do some actions without human intervention. So that's why it is called as autonomy. And flexibility, in flexibility, the agent should be responsive, proactive, and social, so that the task become flexible. And multi-agent systems are designed on so what multi-agent systems means is that in multi-agent systems, multiple agents are involved to do the tasks and to implement the desired goal. So the second one will be autonomous agents. So autonomous agent is a computer system. It works along with humans, with or without. Without human intervention, we will do the tasks. So the three main building blocks of autonomous agents are artificial intelligence, object-oriented programming, and human-machine interface designs. So artificial intelligence is one of the major contributors in the field of autonomous agents for building intelligent artifacts. These artifacts are used to sense and act according to the situations that we usually get from the sensors that we place in our environment. And the other object-oriented programming and concurrent object systems. So the first level of autonomy that agents and objects have is the idea that objects can manage their own internal state and extinguishing the future by using object-oriented programming. And this conventional model says that they can be implemented into various systems to perform the actions autonomously. And the third one is human-machine interface. So we utilize a user interface to engage with the computer, to give some tasks to the computer so that the computer can do the tasks on their own without our intervention. When we are out of some factory or something like that, they'll take decisions on their own. So that is human-machine interface designs. So there are some issues, and there are some issues for these autonomous agents. So these are like, while defining some specific development environments and programming languages, there are no specific languages that are written to autonomous agents. So it is one of the issues that we are facing right now. And after that, we have multi-agent systems. So as I have explained before, multi-agent systems are nothing but taking more agent systems, and these multiple systems are working together to do some tasks is called multi-agent systems. So in this we have, two kinds of methods. Like one is a distributed problem solving, in which the same problem is divided among multiple nodes, multiple sub-agents, where the knowledge of all the agents is used to solve the problem together. And the other one is mass, where it is loosely coupled compared to DPS. So in this mass, every node has specific task, and they will do. Every node performs the task on their own, and at the end they will be clubbed together. Like they are heterogeneous in this nature, so there is no interaction goes in between while doing the specific tasks among themselves. So that's why they are heterogeneous in nature. And the main features of this mass are, they have since they won't have interaction between, they have limited information. To solve the problem, they don't, they have limited capability because of the limited information, and there is no centralized control system for to control the other nodes in the multi-agent systems. This is a brief introduction about multi-agent systems. So from now, Dinesh is going to explain about the application of multi-agent systems in different industries. Yeah, Dinesh, go ahead.
Yeah, thanks, Sai. So now we understand what is a multi-agent system and how it works. Basically, it's just about distribution of work between multiple agents to do or achieve a particular goal. So here, these are some of the industries where we can implement this MAS or multi-agent system we call. So these are the key domains. If you look at the image, we can understand, the standard domains. Manufacturing is one of the major industries for this artificial intelligence implementation or machine learning processing. Apart from manufacturing, we have process control industry, where they use autonomous agents to achieve the desired task. And also it is getting very famous in telecommunications as well, to control the call forwarding or conferences, even roaming kind of thing. So they will distribute each task to multiple agents. So as soon as the task occurs, that agent will take care of the task and go with any associated issues and rectifies the problems for the users. And the agent system is also implemented in air traffic control. As soon as the flight lands in particular destination, the agents take care of the tasks and proceeds with the process until the departure of that particular aeroplane. And it is also used in transportation systems, where the traffic controls and everything will be used. Nowadays, this transportation system is kind of becoming very routine to daily users, to book cabs or pool drives whenever you want to go. So they will assign particular agent to book a pool, and the opposite side agent will receive the request and send it to the cab driver so that it can be achieved. And there are some commercial applications as well, like information systems. So every IT task will be divided among the agents and achieved. And there is also some commerce industry for banking and financial services, or even transactions related anything. So they will use robots, nano robots, to achieve this task. And on the higher end, business process management is there. It's like managing every task within the project, like budgeting or scheduling or analysis. You just name it, from any project implementation life cycle. So they can divide each task to a particular agent to achieve within the given time frame. And coming to entertainment, we have gaming and cinematic industry, where they implement multi-agent system. And also they're using it in medical applications to monitor the patient current condition, or the future situation, how to approach on the medication. and even they're using agents to coordinate with the doctors, specialized agents. Just take an example, like if suppose one candidate comes to the particular hospital with a cancer situation, so that agent will look at the records and ping the particular doctor, so that only the specialized doctor will come and look at the patients to take him to the procedure. So that's how these are the main key domains to implement these multi-agent systems. And we'll go to some of the limitations and issues with the multi-agent system, because I mean we understand that with this concept, autonomous agents, we can achieve a lot of things within a very limited time frame, and also it's kind of cheaper compared to traditional waterfall model work. But there are a couple of major drawbacks to implement this multi-agent system, because it's still new to the industry. Despite being in the development for about 2 to 3 decades, it's still in the process of getting into a future, because there is no a standard methodology to implement this multi-agent system. It's kind of hard to what we say adapt to particular process to implement any kind of multi-agent system within the organization. And the other drawback is we don't have a standard toolkits, like I mean there is a compliance body to take care of everything, but it's still under process, right? So as soon as we get the particular standard toolkit to implement such processes, it will make a lot of things easier. And and also there is some other thing we have to keep in mind. There is a human factor, right? So we cannot give everything to the agents or personal information, or the trust. For example, I'm making a transaction, right? Banking transaction. I'm trusting the bank agent basically with my money. So that trust should be there. And the same concept applies with the various industries. So we have to trust the agents, and also agents should have a specific limit in executing particular tasks. They should not overdo it. Suppose I make a transaction of 10,000, agent thinks that it is 100K, then it's not going to work like that, right? So there should be a mutual understanding between agents and the human. So these are the drawbacks. And this artificial intelligence, or we call it machine learning, it is kind of very famous these days. And definitely there are use cases for real-time implementations. If you go on to next slide, we can see all the industries that are already using this multi-agent system. In manufacturing industry is one of the largest areas, which are widely using artificial intelligence to scan the images, or they use it in multiple layers basically. In manufacturing, there is plenty of layers, right? From product design to production. Even they look at the quality of the product and the measurements and everything. So they will assign each task to a particular agent, and the agent will take care from there. And they will also help in finding the failures or defects in particular product, and raise it to the management. And in banking, as I was talking, there are some robo advisors to help the customers with the suggestions, or advisors in investments kind of thing. And in transportation, even we're looking at current market, they introduced self-driving vehicles, right? From Tesla, Uber, or Volvo, or Volkswagen, you just name it, it's kind of booming these days. So that's a trend. And coming to entertainment, I mean, we can simply see Netflix or Amazon Prime videos as examples. If you look at their website directly, it will give you the choice of options based on your previous history. That's the kind of artificial intelligence. in execution. And coming to healthcare, IBM, they introduced IBM Watson as a medical assistant to achieve the task for the doctors, or even help the patients with it. Even in retail and commerce, as we were talking, Amazon and eBay, these are the platforms help us with the related products or transactions kind of thing. In food processing, there is Tomra. Tomra is one of the companies developed a food processor to assist with the food control, because when a company is manufacturing something related to food, they should take a lot of measures, right? Because end of the day, it will affect them in a hard way. If some complaint comes from a customer or from consumer board, there is a chance of closing the industry. I mean, they're old company, so they'll take specific measures. So this AA helps them in plenty of ways to do that, to control the quality of their products, or fat content or any chemicals. So this multi-agent system helps them in a large way. So that's how the real world is adapting to this multi-agent system. So now we understand about multi-agent system, and also the applications or key domains, and some use cases. Now Tiona will take care from there.
So I will talk about the multi-agent system, the learning for engineers. So first I will cover in general, like the definition of multi-agent system, and then we will see the concept. Later we will see why multi-agent learning. Then I will cover some advantages. And lastly, I will talk about limited information and costly communication. Let's see the first one in general. What is a multi-agent system? So multi-agent system is a system that is computerized and that contains multiple intelligent agents. Multi-agent system is capable of solving problems that are difficult even for humans to solve or for just individuals to solve. It is a system that includes multiple decision-making agents which interact in the same environment to achieve common goals or conflicting goals. It is a system that is mostly used in engineering and technology. Some of the applications where we can find these systems are online trading, disaster response, target surveillance, and social structure modeling. This system finds the best solution for their problems without intervention. The purpose of a multi-agent system is to assist in the design of complex systems that is hard for only individuals to solve it alone. We can go to the next slide and see the concept. So like we said, the multi-agent system is a system that contains two things, which is agents and the environment in which those agents are working in. So multi-agent system usually is looking for software agents. The agents in this system can be robots, humans, or human teams. Those agents, they are divided in three parts, depending on their complexity. So we have passive agents, or agents without any goals. We have active agents that have simple goals, and then cognitive agents that have complex calculations. And then we have environments, and those environments are divided in virtual, discrete, and continuous. The environments can also be organized according to properties such as accessibility, determinism, dynamics, and so on. We can go to the next slide. So let's see why multi-agent learning. It is very difficult to design a distributed control system. Some of the issues are scheduling in manufacturing system, routing in data network, and command and control of network forces in the environment. Also, some of the advantages to the task are local and dynamic information, limited communication capabilities, uncertain environment, and faculty components. You can go to the next slide. So, except of the disadvantages, there are many advantages of the multi-agent system and learning, and some of them are the multi-agent system distributes computational resources and capabilities across a network of interconnected agents. The multi-agent system provides solutions in situations where the expertise is temporarily distributed. The multi-agent systems allowed for the interconnection and the interoperation of multi-existing legacy systems. The multi-agent system enhances overall system performance. The multi-agent system describes problems in teams of autonomous interacting component agents. And then lastly, I will talk about limited information and costly communication. So the most important thing for this multi-agent system is the information available for each agent. So for example, here, this is whatever the agents have access for some informations, or he has only access to his own informations. Another issue is when the agents have the access of utility function of other agents. A lack of utility information can cause uncoupled learning, and its consequence, the consequences are really bad. Sometimes are resolving limiting behavior of certain classes of learning dynamics. On the other side, in the engineering system, the information available is a design consideration that is influenced by the domain. An example of this is knowledge of the utility function of other agents. This knowledge can be communicated among agents when the agents are programmed components. We really appreciate everything that is given to us, like these papers. We really appreciate that we have this chance to read these papers and to learn more about multiple agent systems and overall for the artificial intelligence.
Yeah, thanks guys. Thanks for the opportunity.
Thank you, David Dai, for this opportunity, and thank you, Sai, and thank you, Tiana.
Yeah, thanks guys.
Thank you
I'm
too.
gonna stop the recording.